In this lesson, we're looking at finally how these sinusoid functions can shift. So once again, notice the general equations for the sinusoid functions, sine and cosine, and see how the values of c and d are where we used to see the values of h and k. And they perform in very similar manners. We just use different terminology, so when we're using c to shift the function, we're actually finding the phase of the function. So when we're thinking of c and how it's going to shift our graph, this is what we must perform. And then the k value in our old graphs is this d value, and it does exactly what you would think it's going to do. It moves it up or down based on it being positive or negative. So here, it's asking us to state the amplitude, period, frequency, and phase shift of the function. So the amplitude is designated by the value of a, remember. So amplitude is 1. The period, remember, is found by taking 2 pi over the value of b. So 2 pi over 1/2 is 4 pi, which means that the frequency is once every 4 pi. And in order to find our phase shift, space here, that is the negative of the c value, which was pi over 4, divided by the absolute value of our b, which remember was 1/2. So that means that our phase shift is negative pi over 2. When we are graphing these, hopefully by now you've gotten the hang of the pattern of how these graphs look, where they start, at what point, based on our period, the function recycles itself, what's happening kind of at our halfway points. And so maybe, hopefully, by now, you don't need the standard function in our graph anymore. That's what I'm hoping for. Because since we have an adjusted period for our graph, as well as a phase shift, the way that I want to graph my starting function is I want to graph an f of x that is the cosine of x over 2. So I want to graph a cosine function that has a period of 4 pi that's still starting in the same place and ending in the same place as a function with period 4 pi would do, and then I want to phase shift it. Okay? So since the period of my graph is 4 pi, I'm going to break my grid lines on the x-axis into pi's. So here's 1 pi, 2, 3, 4 pi. The instructions ask us for 2 periods of the function. So 4, 5, 6, 7, here's 8 pi. And let's start with, I'm going to make this positive 1 and that negative 1. Okay, so graphing my f of x in blue, I would have the function starting at a y-intercept of 1. It recycles itself after 4 pi. Halfway between those two maximums, I have a minimum. And halfway between my minimums and maximums, I have my x-intercepts. And I'm going to do the exact same thing after that 4 pi since the instructions ask us for 2 periods of the function. So goes down and then back up. So here is our too high. It's curving back down. Okay, so there's my f of x, the cosine of x over 2. Since down here we established that this graph has a phase shift of pi over 2, I'm going to take all of those significant points that I plotted before connecting the dots to make a wave. I'm going to take each one of them and move them to the left half a pi. So every box is 1 pi. I'm moving all of my points to the left half a box. So here, here, here. That's it. For part B, our instructions again are to state the amplitude, period, frequency, and phase shift. This time, notice the A value is 3, so it has an amplitude of 3. The period is 2 pi over 2, which is just 1 pi. A frequency of 1 over pi, meaning that it has 1 cycle every pi units on the x-axis. And my phase shift is negative, my C value is pi over 3, over my B value of 2. So that simplifies to negative pi over 6. So in the interest of my graph, I'm going to make all of my I'm going to break my x-axis down into thirds of pi. So that way when I'm phase shifting, I'm basically doing the exact same thing that I did in the last example. I'm going to be moving to the left half of a box. But because my units on my x-axis are different, what I'm actually phase shifting is negative pi over 6. So again, let me reiterate to you, most of the heavy math lifting that you're doing comes down to how are you labeling your axes. So now that I've labeled my axes, let's remember what the sine function looks like. It has a y-intercept of 0. Since this graph has a period of pi, it's going to recycle itself at pi. So there's my ending point. Halfway between my starting point and my ending point is another x-intercept. And then halfway between my intercepts are my maximum and my minimum. So my maximum is about here, and my minimum is about here. And the instructions asked for 2 periods of the function, so I'm going to just redo those points. So I have another x-intercept at 2 pi, another x-intercept at 3 pi over 2. I have another maximum between pi and 3 pi over 2, so about here. And another minimum between 3 pi over 2 and 2 pi, about here. So there's our f of x, which is 3 sine 2x. Since I made my x-axis, each box represents pi over 3, so when I calculated my phase shift of negative pi over 6, what I'm basically doing is taking all of those points and moving them half a box to the left. Now, is this going to be the most precise looking graph ever? Probably not, but hopefully you kind of get enough of an idea of how all of these pieces of the puzzle work together. So this is half a box to the left. This is about half a box to the left. Half. Half. There's our graph when we connect the dots. Hopefully you're going through your dots better than I am. But again, probably the most important thing is being able to calculate all this stuff and understand where it plays into your graph. The last thing we're looking at naturally, since we've talked about horizontal compression, vertical expansion, and horizontal expansion, we've talked about horizontal shift. Finally, vertical shift. So the amplitude is still my A value. My period of the graph is, oh, that's convenient, it's 2 pi. I don't have any phase shift, but I do have a vertical shift of 1. Is it asking me to notate that? So period is 2 pi, that means the frequency is once every 2 pi. Phase shift is 0, or no phase shift. Vertical shift, up 1. All right, since it wants 2 periods of the function, and each period is 2 pi, I'm going to make this go out to 4 pi. 1, 2, 3, 4. There's 2 pi. And it's a cosine graph. So my f of x graph that I'm going to draw is the 2 cosine x. And then I'm going to shift that up 1 space. So, y-axis, let's make this 1 and, oh wait. In the interest of accounting for the amplitude as well as the shift, I'm going to make every 2 boxes 1. So 1, 2, 3, 4. Okay, my f of x graph. It's a cosine graph, and it will have a maximum at the y-axis. Because my amplitude is 2, its maximum will be 2. It's going to repeat itself every 2 pi. Halfway between my maximums are my minimums. And halfway between my minimums and maximums are my intercepts. So here is my f of x graph. And then it's getting shifted 1. So I take all of those important points that I just plotted and move them up 1 box, or 1 unit. Dots, and you're done. In part B, we have quite a bit going on. We have a different amplitude than our standard graph. We have a different period. We have phase shift, and we have vertical shift. So let's identify all of it before we figure out how it's all going to fit on our graph. Okay. So amplitude is 1/2. The period is 2 pi over 1/4, which is 8 pi. The frequency, therefore, is once every 8 pi. Oh, this looks very messy and hard to look at. We said that our frequency was once every 8 pi. And then the phase shift is negative. Our C value is pi over 2. Oh, be careful. Let me bounce that back up there. It's actually going to be positive pi over 2 over 4. Because notice that this time our C value is negative. So our phase shift is pi over 2 over 1/4. Which means our phase shift is actually 2 pi. Ooh. Okay. So how's this all going to fit on our graph? It wants 2 periods of the function, which means in order for us to do that, we're going to be using the positive and negative side of the x-axis, because I need the period of my graph to get to 8 pi. So here's 8 pi, here's negative 8 pi, and so what I'm going to start with is my modified period and modified amplitude graph, and then we'll phase shift it. Okay, so every box is 1 pi, so we will be able to shift this 2 pi and still have 2 periods on our grid. All right, so I'm going to make every 2 boxes be 1. So this is a sine graph. We know that it starts at 0, 0, because this graph has a period of 8 pi, it's going to recycle itself at 8 pi. I could think of it as recycling itself at negative 8 pi as well. Halfway between those intercepts is one other x-intercept at 4 pi and negative 4 pi. Halfway between my intercepts are my maximums and minimums. So notice before we plot them, our maximums and minimums are going to be 1/2 and negative 1/2 before we vertically shift anything. Okay, so here's my maximum, minimum, minimum, maximum. And here's our f of x graph. Which is 1/2 the sine of x over 4. I have not yet phase shifted it, and I have not yet vertically shifted it. We may have forgotten to indicate that down. It's vertical shift. Shift down 3. So now I'm going to take these significant points that I plotted, the x-intercepts, the maximums, the minimums, everything that I plotted before just connecting the dots, I'm going to take all of them and move them to the right 2 pi and down 3. So starting from the left, I'm taking this point all the way at the left at negative 8 pi comma 0, moving it to the right 2 pi and down 3. Taking everything and doing the same thing to it. So moving it 2 pi and down 3. 1, 2, 3. And when we connect our dots, there's our